All right, hello, Mark. Thanks for joining us. Can you just give us a bit of an introduction to yourself, please?
Yeah, of course. Great to be here, by the way. So thank you very much for the invitation. So my name's Mark Yeeles. I'm the VP of what we call our secure power division here at Schneider Electric in the UK&I zone. I wear two hats, really, I suppose. So for Schneider, I have a responsibility from a P&L standpoint for the particular group of products, solutions, services, and software. And I also am very proud to represent our organisation from a data center standpoint as well in the same zone, so in the UK and Ireland. So, yeah, and I guess my history, just a brief history, is my use of data or management of it was very much the other side of the fence until more recently. So, I'm a software, robotics, and automation guy by history and legacy, I suppose. But here I am on the other side of the fence trying to provide the infrastructure that supports that.
Yeah, so let's get right into it, Mark. So how is AI's growth fundamentally changing data center design, especially regarding power and cooling?
Well, I think especially AI growth, it's fundamentally reshaping data centers, isn't it? I mean, we're seeing a shift to those higher power densities. I mean, every time I turn a corner, it feels like NVIDIA are launching a new product or a new chipset. So this is making it really interesting for us as a technology provider, thinking about those higher power densities and then making liquid cooling almost essential. And it has to be said essential alongside those air systems to help keep operations both efficient and resilient. So, the what we've seen recently with the UK's AI infrastructure push with the likes of Microsoft, NVIDIA, Nscale, OpenAI, we put those in there too. It underlies the urgency of the shift and the thinking that we need to undertake to make sure that we're prepared for this new wave of AI infrastructure. Now, I guess when you think about that comes with its two areas, and I've alluded to it already. So we're thinking about power and the density of power in the racks, and we know that AI clusters are now reaching somewhere around 70 kilowatts per rack, and we know there's a reference designs out there that are somewhat higher, and we've been involved in some of those design discussions already. You couple that then from a power perspective with the massive global demand. Of course, it means an increase in power. And in particular around AI, you can see by some of our studies and some of the stuff that we've looked at in the market would tell us that around about 36% of all workloads actually will sit in this AI space and take that capacity of data centers by that 2030 mark. So look, I think it's going fast. And then of course there's the whole power, and I think about this from a grid to chip perspective. There's a whole host of different technologies and the way that we're thinking about designing those technologies that need to be fit for purpose in that space. And I touched on, didn't I, on the cooling aspect earlier. Liquid cooling it's an essential. It's not a nice stargazing, nice to have. It's really taking the fold at a rapid rate, and we've seen that by the own acquisition in our own company of Motive Air with with that particular skill set around liquid cooling, especially around the AI chipsets, I would say. But look, I think air cooling will still have a role to play. It will just diminish over time, and of course. I suppose the other thing to say is, as I touched on earlier around power, from an efficiency and a sustainability perspective, new high temp chillers and those liquid to liquid systems will ultimately improve efficiency. That's what they'll do. They'll make it for a much better solution, and hopefully in the future, through the use of AI, we'll be able to drive that efficiency back into the system. And I hope, like they do in the Nordics, we will here in the UK be able to find a way to reuse that waste heat as well.
Yeah, so looking at staying on the physical side of things, what are the main infrastructure challenges in these high density AI growth zones compared to a more traditional data center?
Well, that's a great question, isn't it? I mean, I think the AI growth zones present an exciting opportunity. Number one, and we are particularly excited to see where the zones will end up. We're seeing glimmers and shoots of maybe informal announcements of where these growth zones will show in the future. But we're excited to see that that disperse across the country and not just on the M4 corridor and sort of around the London area. So we're excited for that, first of all. And I think it gives us a new opportunity, doesn't it, to kind of reimagine the data center landscape with, maybe new power thinking, new power strategies. And I lean into a conversation I had with a client earlier this week in Scotland, just talking about renewables in that region. And I think, I look at that and I think, well, what an opportunity to do something really. One, it's quite cool. Excuse the phrase, but it's really quite cool. And also, it helps us lean into some of those sustainable power gen topics. So I'm excited to see how that might disperse across the country, because there are challenges. I mean, the government have made a hefty commitment, but within those growth zones, we've got to secure over 500 megawatt of power capacity just to meet the demand of all of those zones. So that's gonna come with its own challenges, and we've seen with the influx of investment, as I said, from last week alone from Nvidia and Microsoft, that's gonna challenge and stress our grid capacity. So really, we have to look at this in two ways. I think we have to look at it from a power supply perspective. How do we break through red tape to make that easier? And also, how do we really lean into those renewables to help us, become and drive down the carbon, but also make us equally as competitive from a cost standpoint. When I think about per kilowatt hour as an example. So, infrastructure challenge, that's number one. So number two, then, and we touched on this earlier, was around cooling and heat. So, without question, air cooling is, as I said, probably on the decline. But we also need to think about, so how do we cope with that? And of course, liquid cooling is a strong candidate, of course, to become absolutely pivotal in helping us cool down the chipsets of the future. So cooling and heat will take on, I think, a different dynamic in the next few years. And I can speak for Schneider Electric. Hence the reason for Motive Air and our purchase of that organisation was to help us get access to this direct-to-chip chilling technology right now, because we see that as the growth engine for the next few years. I mean, one of the things that, whilst we're very keen supporters of data centres being dispersed across the UK, it comes with its own challenges and opportunities, I suppose. So, I look at this and I think, well, how are we going to cope with this from a skills, a workforce perspective, just in terms of numbers, ignoring talent for a moment, just in terms of numbers. So, I think there was a recent survey and a report published where 94%, I think it was, of UK data center developers say they're going to struggle to find those skilled staff, and that will come with its own challenges. But I'm pretty confident that organisations like Schneider, in collaboration with the complete ecosystem, can help educate, charge and I say this, our young people, to help us navigate our way through the next period. And then, of course, the one thing that we welcome from the AI growth zones is hopefully the ability to streamline approvals and make it possible, for neo clouds like CoreWeave and Nscale to deliver at scale and pace capacity to support what the UK's, I said, overall leadership in AI is trying to get done. So again, that's what we see as another challenge. But I'm hopeful with the AI growth zones, we can take some of this red tape away.
Yeah, absolutely. It's going to be interesting to see how they develop. So moving more on to the sustainability, I know you touched on it earlier. Why is an energy efficient power infrastructure in these AI growth zones now so crucial for both uptime and sustainability?
Well, I think when you look at our industry, we have to acknowledge that as it grows, what we can't accept is growth and power hitting the same charts at the same pace. So we can't accept that. So I think and this is the challenge, right? So we just can't accept that that's going to be truth. So what do we do? Well, I think we need to think about. I think you said it there. It's about uptime and it's about inefficiencies as well. So they're the two dynamics of this, I think. And I certainly know from our perspective, we try to work very closely with our clients to help drive out both. And I think there's two angles here as well. If we dig a bit deeper, there's the not using energy, so making yourself more efficient because that's the cheapest energy you ever use is the stuff you don't. And also then it's about how do we actually utilize AI, and how do we drive efficiency, cost structure, and make our cooling offers as energy efficient as we possibly can. So I think that's one angle. Um, and then we have to think about, I think climate is a really important topic for us. And as I said earlier, sustainability is one angle of this, but I also believe baked into sustainability is the way we build DCs. So I've been speaking to some very cool people recently, been talking to us about using a certain form of algae on the side of either buildings or modular data centers, and the algae can take down the temperature of a data center or a modular data center by 5 degrees. Now, that might not seem insignificant, but it's 5 degrees we don't have to worry about now. So I think there's different ways of attacking this, and I think the final piece on this is why this is why initiatives like the UK's AI Energy Council, in partnership, let's be clear, in partnership with NVIDIA and other GPU providers as well, and some of our customers in Vantage, KO, and Digital Realty, plus I suppose those GPU as a service providers like Nscale, are essential for matching economic opportunity with those. The best way to describe them is future-ready infrastructure projects, with sustainability at core. So I think it's a real dichotomy of balance, but I think we can get there.
So perhaps looking in a bit more detail, how are Schneider Electric solutions helping your customers to manage power and cooling demands?
Yeah, this is a great question. So I think some of the things that we start to think about here is, and this would have taken place probably 2 or 3 years ago, was for us to think about end to end. Do we have a full portfolio? Yes or no? So now we believe we have, and now we have a full end to end portfolio. Well, what solutions can we provide within the kind of basket of opportunity throughout the whole stack? So that's first thing to say. And then where are there opportunities in each of those layers of the stack? Where can we make a difference? So I think if I look at what we've been doing in particular, I mentioned the Motivair piece, earlier. These guys have been in this for 15 years in liquid cooling. So it's really on us to leverage their technology and their expertise around 15 years of gaining knowledge in the industry. And let's not forget they power 6 of the world's 10 most powerful supercomputers. So they kind of know what they're doing. And they've already delivered solutions that are in AI racks as of today. So and again, if you partner, our Motivair division up with NVIDIA, we believe we stay years ahead of the market by doing that. So I think that's one aspect. And it's also as I mentioned earlier, it is the end to end, but also it's acknowledging there are opportunities within, but then what tools exist to help us make that a reality. So I think about digital twins. I think about utilizing software to drive down PUE. I think about how do we best use the technology to drive out carbon from within the installation itself. So I think it's important to recognise that a full portfolio does allow you to think differently when you're deploying new technologies. And I do believe, and I held an event last week in London that was not primarily, but one of the focus angles there was the ecosystem. And I think it's really important to think that we don't have all the answers, but maybe our partners do, or maybe our buddies do at Nvidia, or maybe one of our OEM partners like a Dell or an HPE may well have a solution there. So I think it's really important to think about the broader picture, and then from a power standpoint, we're also starting to think about how do we best deploy microgrids as one example, which can enable data center operators to power their infrastructure off grid. Now, it does require, as I may have touched on earlier, maybe wind gen, it might require battery storage, a little bit of solar. So there are a number of different facets to this, but maybe this is the time for us to start thinking a bit broader about how do we solve for the bigger challenge, which, as you quite rightly asked in your question, is how we helping customers manage their power and cooling demands.
Yeah, so I think you touched on something similar in your introduction, but considering your background in industrial automation, how is the convergence of IT and OT systems creating these operational complexities?
Yeah, this is a really good question. So I think the convergence piece is something that industry has been trying to kind of understand and better solve for over a number of years. Actually, I think the great thing we're seeing in the more recent past is that we're making this easier and easier, and actually AI is enabling that. Okay, so it's becoming easier, not easy, but easier to get hold of the data from manufacturing plants and to make a real difference to their facility by sucking up the data, having it in one version of the truth to present back some of the opportunities for further improvement. So I think it's made. Actually, I think we're solving for some of the complexity in this space. So I think that's one thing you can say. But then if I think back and I pull myself back to that whole IT OT space, as I think about synchronizing power and cooling in real time, as AI workloads, let's be right, and we mentioned it earlier, they're driving racks to unprecedented densities. IT and OT kind of infrastructure must now it's got to work seamlessly to help manage for the power and the thermal performance minute by minute, in some cases second by second if you lose a grid connection, as an example. So this isn't just a challenge, it's actually an opportunity to design and deploy smarter, I believe. And actually what we are seeing is, and we've seen this for a few years, actually we're lucky at Schneider Electric to cover a multitude of different segments, is AI being utilized to monitor and predict our own products' performance in clients. So that's one of the complexities we're solving for. One of the things that is a real perennial challenge for us all is, how do you embed some cybersecurity in the infrastructure, and that's a biggie for us. But I would say, and I've been advocating for this for a little while, with data centers now being recognised. I used to call it the fourth utility, but I'm happy to kind of say that the critical national infrastructure inclusion of data centers last September, gives our industry a new level of exposure, and I think we should lean into the other three utilities to understand better how they've been solving for this challenge around cyber for so long. And I think there's perhaps some cross-breeding, cross-fertilizing of expertise in that space, without question. The other complexity, again, coming back to the kind of skills, bridging skills into this industry, it's how do you bring those skills together? Because I think if I think about my team or the teams that work around us, they're very diverse. Some have got a graduate background, some haven't got a further education on their CV at all. Some of us have got apprenticeship background, so we all have a different perspective. And I think actually, by investing in apprenticeships, cross training, cross fertilizing, even across industries, creates diverse pathways where you can kind of bend and swerve into different parts of different industries at different times, dependent on your desire and skill set. So So I think there's quite a bit here just around that bridging skills topic,
Mm.
and I think one of the things that's probably upon us is to understand that both the digital and physical side of infrastructure needs to be better understood. And I think the new generation of professionals probably have a really good sense of both sides. So, I'm very positive around the skills piece, and especially around early talent. I think we've got, what it takes in this country to enable us to scale.
Yeah, absolutely. So how does Schneider Electric's EcoStruxure platform provide real-time visibility and proactive management for the physical layer of data centers?
Well, again, I think we did touch on this, but EcoStruxure IT is our dedicated software platform, and it actually uses, as I mentioned earlier, the AI tools and data and what we would call machine learning to make data centers more efficient and sustainable, and of course, we mentioned it earlier, so certainly resilient as well. And look, I'm really proud to say, there's some great examples out in the market. So, Welcome Sanger Institute in Cambridge, the UK, helped cut energy costs by just over 30%, 33% it was, just by utilising the tool to become more effective. I use another example in the Nordics. Eco Data Centre runs a 99% UPS efficiency program with EcoStruxure, while supporting a 1.25 megawatt load. So there are instances around the globe of where we can utilize EcoStruxure IT to help drive costs out, and we and we try and do this all the time if we can. And so we've drunk our own champagne, and we utilize EcoStruxure IT in our Lexington smart factory, which is actually where we produce some of the older products that I would have known quite well. And again, that was a great case study, great story for us, because it drove out 30% again of energy cost and driving out carbon only after 6 months of use. So so when I think about that, it's it's actually quite warming to think, how can we do more in this space, and share a bit of the knowledge that we've gained with the broader use and broader tech that we have. And the piece on the Lexington story that I found really interesting. So not only did we cut CO2 by 30, we did it in two areas. So we did it one in the electricity piece, and also in lower water usage. And this really is all about giving visibility to decision makers. So how do we make it really easy for a decision maker to decide whether his flow is too high, too low, and whether we can turn it up or down in real time? And we're proud to showcase this for customers who want to understand how that maybe they could get more from their own facilities.
So looking ahead to the future, what is the next big challenge for data center infrastructure, do you think?
Well, I think there's probably three areas. I think first area is power and power innovation, and I think everything that I've seen around power. There's a couple of points on it. One is the loads. So you see a big fluctuation in load. So you think, that's going to cause us some R&D challenges. But organisations like Schneider Electric are working out better ways to do that. And the rapid growth you're seeing it's a catalyst for changing, and it's it's also driving the way we may think about buying and procuring energy. So when the numbers are so high, then partnerships with organisations like Schneider, who procure power on behalf of our customers, $45 billion under contract, and who embrace other energy sources, more sustainable energy sources, will ultimately be maybe more attractive to some of their investors because of that topic. So I think that's one big challenge is power, availability of it, getting hold of it, and making it most sustainable. Then I think how do we make all of this infrastructure more efficient, and in particular with the GPUs and acceleration of performance. We as a technology vendor need to be wrapped around the developments of these chipsets to see how we can unlock new levels of optimization, performance, and reliability by utilizing technology, like I mentioned earlier, around liquid cooling. So I think that's another big challenge for us. Um, and then, as I mentioned earlier, I think the third point is how can we be seen as leaders on sustainability in our industry, because we've got a PR challenge to address. Let's get it on the table. It's well known that data centers do consume lots of power. So I then feel that the opportunity for us is how do we decouple that growth, so our graph kind of like spreads apart from both an emission standpoint, from a carbon standpoint, embedded carbon, embodied carbon, and also thinking about, well, how do I invest in renewables? I mentioned earlier about people building data centers in Scotland where there's a large sum of megawatts available from wind power. Then I think about battery storage and alternative fuels, and I think the data center can lead the way. And the one thing we don't talk about so much is whilst it's a challenge, it's actually a challenge in terms of our own industry, but actually we're solving challenges. I think it's like if I think about my old background, if I was in a food and bev plant and I was using AI, I see that as almost like I don't know, scope 3, I think, if I was thinking about it from a sustainability point of view, to drive out carbon in those areas. So yeah, there are some big challenges coming ahead, but I think the industry is ready for those, and we will have to adopt and adapt as the new world embarks on us, especially around the Nvidia and the way that those chipsets and GPUs are being pushed into the marketplace.
Well, that's all for today. Thank you very much for your time, Mark.
Really appreciate it. Thank you.